Good afternoon, everyone. Today we will be presenting the whale optimization algorithm, commonly referred to as WOA. This is a modern bio-inspired optimization technique modeled after the hunting intelligence of humpback whales. My team, Devansh, Akshaya, and Abhishek, will walk you through the intuition, mechanism, and the working principle behind this algorithm. The whale optimization algorithm is a bio-inspired meta-heuristic developed by Rijali et al. It draws inspiration from the extraordinary bubble net hunting strategy of humpback whales. The WOA functions as a population-based global optimization method, meaning it begins with a group of solutions and iteratively improves them. The algorithm imitates the three major behaviors of whales: encircling the prey, which represents moving towards the current best solution; shrinking or expanding the search boundaries; and spiral bubble net movement, an advanced hunting maneuver of the humpback whales. The beauty of WOA lies in its natural balance between exploration, where the algorithm searches new areas of the search space, and exploitation, where it refines promising solutions. Because of its flexibility and simplicity of its equations, WOA is used to several domains, including engineering designs, machine learning optimization, feature selection, and complex nonlinear search problems. Inspiration and forging behavior of humpback whales. The WOA draws its core behavior from real-world intelligence of humpback whales. These whales are not only large but also exceptionally intelligent mammals. They, prefer, they possess specialized brain cells called spindle cell that allow rapid decision making and social coordination. Humpback whales typically hunt in groups. One of their signature hunting strategies is bubble net feeding, where they create organized spiral or nine-shaped bubble net patterns around the schools of fishes, as you can see in the image. These bubbles form a net-like structure that forces the fish into a tight cluster, making them easier to capture. This elaborate and strategic method reflects both cooperation and precision, and WOA incorporates these aspects through mechanisms like coordinated encircling, spiral motion, and targeted pursuit. This inspiration allows the algorithm to model both local exploitation and global exploration. To local exploitation as in closing in on a promising region, and global exploration as in scanning wider areas to avoid poor solutions. Now the algorithm and flowchart of the WOA. We begin by initializing the parameters for the algorithm, population size, maximum iterations, and the search boundaries for the problem. Next, we generate an initial population of whales randomly and evaluate their fitness. This represents the initial guess of the algorithm. From this population, we identify the best whale which acts as the target or the prey. This best solution is dynamically updated throughout the process as better solutions emerge. The core loop of this algorithm consists of updating the iteration counter, updating main control parameters like AAC1P, applying either exploration or exploitation strategies depending on parameter values, updating the global best solution whenever a better whale is found. This cycle continues until the stopping condition, usually the maximum number of iterations is reached. The final best solution is considered as the optimized output. Now my teammate Abhishek will be explaining you about the unsettling of faith.
In this step, W assumes that the best known solution represents the prey being targeted by the whales. Every whale tries to move closer to the best whale, mimicking how real humpback whales close is on their prey. The distance between a whale and the prey is computed as the shown formula on the screen. Here, X star T is the best position so far. This distance is then used to update the whale's position by the formula X of T plus 1 is equals to X star T minus A multiplied D. This formula helps the entire swan to move towards the best solution in a coordinated manner. It allows WA to exploit the most promising area in the search space effectively. Uh, Next, the coefficient A and C are the controlling forces of the algorithm. They decide whether a whale should move closer to the prey or move away to explore. They are defined as A is equal to 2 into R minus C and C is equal to 2 into R. The variable A starts at 2 and decreases to 0 over the iterations. This gradual decay ensures a natural transition from exploration to exploitation. Where absolute value of A is less than 1, whales focus on exploitation directly moving towards the prey. When absolute value of A is greater than 1, whales perform exploration by searching new areas. This continuous rebalancing prevents the algorithm from getting trapped in local minima early on while still enabling fine-tuned optimization later. Now, next slide. Uh, the first exploitation mechanism is shrinking and circling. As iterations progress, the value of A gradually decreases, which effectively reduces the radius of the encircling motion. This represents whales tightening their movement around the prey, indicating that the algorithm is honing in on the optimal solution. This mechanism is crucial during the later stages of optimization because it lets the algorithm refine the existing best solution with higher accuracy. Now, my friend Akshaya will continue.
I'm gonna talk about spiral updating and bubble net attack. The second way whales exploit the search space is through spiral movement. This idea comes from the helical swimming pattern whales used in real bubble net feeding. In WOA, this motion is modeled using a spiral equation that depends on uh, two things: the distance of the prey and a constant that controls the spiral shape, and a random value between -1 and 1. Because of this, the whale moves around the prey in a spiral path. This helps avoid getting stuck at one point and lets the algorithm refine the solution from different angles. Next slide. Next. So now I'm gonna talk about random switching between mechanisms. WOA doesn't always use the same movement. A random probability P decides whether a whale uses shrinking, encircling, or spiral motion. This randomness makes the movement patterns more diverse. It prevents the whales from getting trapped too early in a wrong solution. Overall, this randomness improves stability and accuracy. So we're gonna talk about the exploration phase. When the algorithm is exploring, the whales stop moving towards the best whale. Instead, each whale moves towards a random whale in the population. This is important early in the run because it forces the algorithm to check far and wide in the search space. It keeps the search broad and increases the chances of finding a better global optimum. Next. Importance of exploration. Exploration is a key part of optimization, and WA builds it in naturally. Whenever A is greater than 1, the modulo of A is greater than 1, whales are encouraged to explore new regions. This prevents from clustering around the first decent solution they see. As iterations continue, the algorithm slowly shifts towards exploration to exploitation. That shift lets WA search widely, then fine tune the promising area. This balance is one of the main reasons WA performs well on complex problems. Thank you.